Hi, my name is Ashish, and in this video, we will see Azure Kubernetes Service application and package management using Helm. So, we will use an AKS cluster to host an application solution, and let's say the DevOps team, who would use standard declarative YAML files to deploy various services in the solution. So, during the current deployment workflow, the development teams create the deployment files for each microservices that they will deploy on the AKS. The team is, let's say we come on a conclusion that we will use Helm as a package management tool for the deployment of the application on the AKS. So in this video, we will install an AKS cluster for the test deployment using Helm, which is a package management tool. We will use a script to create and configure the AKS cluster. So the script would select the subscription and set it as the default subscription for all the deployed resources. It would create an AKS cluster by using the Azure CLI. It will configure a default Kubernetes Nginx ingress controller and the load balancer. It will clone the example application and Helm chart from our GitHub repo. It would also create Azure Container Registry. It would configure an AKS cluster to authenticate to an Azure container. It will install versions .NET Core SDK, and we will run the deployment script, right? So let me quickly log on to the portal and take it from there. I'm logging on to the portal. Let me launch the Cloud Shell. Okay, much better. Okay, I will run the command in the Cloud Shell. So let me run this command again. So it would identify the subscription ID to use, and if I go for the next line, now this would run, right? So this when the dash n would recognize the AKS cluster that this script is defined. It would use the ACR and it would install this, and it would picking up the application from this shell script. So if I click on this link to show you, so this is this shell script that it's using to deploy the environment that I'm going to use in this video. So it would pick up the subscription ID, SDK version, right? It will also use the ACR. Default value is false. It would also install the .NET Core SDK. Okay. Let's see. It is still running. Let me pause the video and come back. All right, the deployment is completed. Cluster name, cluster subscription, cluster resource group. Everything I see is here. Perfect. And now I will create and install the Helm chart. Now, what does Helm chart do? See, Helm chart makes it easy to install pre-configured cloud-native applications on a Kubernetes cluster. Let's say the DevOps team is already familiar with the installation steps to install the application using the manifest files and kubectl, which is the command line to interact with the AKS cluster. Then let's say the team decides to install an ASP.NET Core Helm chart to test the Helm installation process. So in continuation, we'll add a Helm repo to this Helm client and install an ASP.NET Core website onto the AKS cluster. All right, so in the Azure Cloud Shell, we will add the Azure Marketplace Helm Repo to the Helm client. So this repo will give us the access to a number of pre-configured Helm chart. So if I have to tell you that what exactly is an Helm chart. So Helm chart is a templated deployment package that would describe a related set of Kubernetes resources. So it essentially would contain all the information required to build and deploy the manifest files for an application to run on the Kubernetes cluster, right? So it would consist of several files and folders to describe the chart. All right, so let me run this command. So I will do this, paste this command. Helm repo add this from this URL, right? I hit enter. So Azure Marketplace has been added to the repos. Okay, so I will use Helm. You know why I'm not able to type here. Let's try open up the duplicate browser and I'll launch the Cloud Shell here. Let's see how it goes. Okay, so Helm repo list. I added it. Okay. Let me restart it. In case if it happens with you as well, so try and restart the Cloud Shell. Maybe it will fix that. Okay, my Cloud Shell is back. Let me let me add the repo again. Okay, I added the repo again, Helm repo add command, and then it showed up. Perfect. Now you see that it returned the result that I have this marketplace. This I have added the repo list on the Azure marketplace, right? So I will now search repo command to search for the Azure marketplace ASP.NET Core chart, right? So I'll do Helm Search Repo ASP.NET. Simple. So I have this. The name is ASP.NET Dash Core and the chart version is this. Is an open source framework. Perfect. I will deploy this Helm chart, right? So I will do Helm, I'm sorry, Helm Install ASP.NET dash web app and the name is Azure dash marketplace ASP.NET dash core Helm repo update. Okay. So it's updating the latest repos. I'll do this again. Okay. Let me run it again. I ran it again. Let's see if it installs or not. I'm hoping it would. Okay, it does. Okay, great. So it gave me the output. So the output that you see is generated from the templates notes.txt file. The information displayed from the is generated based on the template defined in the file. So it is already defined in those files in the YAML file. So if you would see the name here, right? Last deployed, namespace, status, revision, test suite, right? So it is the name. If you see the ASP.NET dash web app is used to create the DNS name. I have the DNS name as well to which the request would be served, right? And you will also notice the notes displays here. It says ASP.core can be accessed to the following DS name from within your cluster. So any application that is deployed within your cluster is not exposed to the internet. You have to uh, enable the ingress controller to expose that application to the internet. And the default release does not include an ingress as part of the install. So, but Helm allows you to query all the installed release on the cluster, right? So if you would do Helm list, so this is the ASP.NET web app. It's in the default namespace. Its update is status deployed and all the version. All right. So notice the name of the release and its revision number. The name and the revision. This part, the first three things. The name of the release is import. And you will use the name to reference the release. The revision number increments each time we make a change to a release. So every time I deploy the updated version of this application using Helm, I would see that the revision number would be bumped up, right? And Helm also allows us to fetch manifest information related to each release. So if I do Helm get manifest ASP.NET, this is it is the related release or the code, if you will, right? So, so if you would see the three YAML files, let me show you. Tu, 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 tu. You see this? We have service YAML, we have service, we have deployment. These files are rendered based on the combination of the charts available templates and the values available in the values.yaml file. And if you want to validate that the pod is deployed, you would use the normal command of kubectl get pods. Right. The pod is deployed. One pod is deployed. It's running from 4 minutes. IP is this. It's in this node pool. Right. Now, if you want to, for the sake of this lab, let's delete the Helm release. Helm delete ASP.NET web app. So it says release ASP.NET web app uninstalled. So we will install a Helm chart with the set values. We may override values for a Helm chart by passing either a value parameter or we can have our own values.yaml file. For now, we will use the following command that I will run to see how to update a value using the set parameter. Right, so let me do this. So I'm doing Helm install set. The replica count should be 5 and the ASP.NET, the same application. Right, so I'll hit enter. I'll have 5 replicas now, right? So I will have 5 pods running for the same application for which I was having just one. So if I do kubectl command get pods again, you see I have 5 pods running because I have 5 replicas of the same application and they are all running in the same node pool. Awesome. And you can delete it again. Next, I'll show you how to manage a Helm release. Right. So, as you know, the Helm charts make it easy to install, upgrade, rollback, and even to delete an application on the Kubernetes. So, let's say our team was successful in installing the pre configured Helm chart from the marketplace because I just added that Helm repo in the Azure marketplace and then deployed one application using Helm chart from the Helm repo. Now, to test the management of release upgrades and rollbacks, let's say our team decides to simulate the experience by installing a basic .NET Core Blazor server application. So, right, we will customize an existing Helm chart to install, upgrade, rollback, right? So, let's review the Helm chart folder structure. So, I'm going to list the contents of the Helm repository to locate the file. So let me do this. I'll do this. These are the files, right? So I have ASP.NET Core TGZ file. This command returns. So all Helm chart installed from the repositories are cached in this folder. So if you are interested in inspecting or modify the contents of a chart, you can extract the zip package and from the cache folder and install the charts as a local chart. So for this video, the chart is already unpacked and available in the cloud drive. So let me inspect the existing Helm chart by recursively listing all contents of the chart folder. So let me browse to that directory. So I am in the source folder, cloud drive MS Learn, and I'm gonna do find the charts inside this pre-configured Helm chart that I extracted from the Helm repo. I'll do print. So these are all the YAML files. And this is the chart.yaml file that I was talking about, right? So if you see this, the chart.yaml file, the one I have highlighted, you all will also see the values.yaml file. Maybe. Oh, I can see you. Here it is. Values.yaml file, right? And the number of templates and an empty chart folder. So let me open up the chart file, right? So I'll do code drone web app dash chart, and inside I'm gonna do chart.yaml. This will open up that file into the code editor. You see the YAML file. So now if you would see the dependencies, version repository from this repo, bitnami common, right? So now I will run the Helm dependency build command to download and update all the chart dependencies. So I'll do close this one, right? He's using that chart.yaml file. If you want to review the files in the drone web app chart folder again, let me do this. Find drone web app dash chart. I'm going to print it, right? You see all the files here, right? An updated subchart named common is now available in the charts folder. So if you, hey, you see all these things, right? This is updated, and you can see the contents from this folder if you are interested in the content, right? So you can use gzip command for this particular directory, and you can unpack the files and you can see the folder contents in will, right? And if you want to review the values.yaml file, let me do this. Code drone web app dash chart values.yaml file. This is your value.yaml file. Now there are a number of sections that are of interest in this file, right? Let's review them and how they impact the final deployed app. So if you would search for the image value to see which image is being used, right? So they're using this image from the docker.io repository. And if you would see the Bitnami ASP core repo, and they're using this version. The image is the app's base image and contain an installation of ASP.NET Core application. And if you would search for the app from external repo value, you will use these values you to generate the deployment of your YAML manifest file, right? So if you want to use app from external repo, there you see enabled. Clone this version. So there are several items here, right? So the Bitnami Git image, the Bitnami.NET SDK image, the GitHub repo, the app source code repository subfolder. Each of these values is used in the deployment templates for the deployment.yaml file. Now, if you would search for the ingress value in the values.yaml file, let me scroll down, right? Let me find ingress, right? It is set to true cert manager. Fall host name is this. And this section would allow you to configure many aspects of the final ingress file. For this video, we are only going to use ingress.enabled value. Now, if you want to see the deployment file, let me close this. And I would drone.webapp dash chart templates deployment.yaml file. This is the deployment.yaml file. Notice that this file has the structure of a deployment manifest, but the final information that goes into the file is dependent on the values from the values.yaml file. So if I so if you want to see the spec.replicas, right? So if I do control F, spec and name, everything else, right? You see, so now I can deploy this dot. Let me close the editor. Let me do Helm install drone web app, drone web app dash chart. Now we can view the installation process by running the kubectl get node. So let it do it. So obtained URL. So this is the from within your cluster, and if I want to click this and see, I cannot reach this page. So I want to, so this app is running now. I want to open up the load balancer IP address in a browser to see the web app running, right? So what I'll do is I will see cat. Let me run this. I want to export this file. So this is my load balancer IP. Copy, paste, enter, temporarily unavailable. Right, so now you know how you install it, right? And if you want to update anything, you can open up the chart.yml file. You can update the app version to the latest version. Then you will have to again deploy the Helm app, and you can then it would update the bump the revision number as well, right? So this is how you do it, right? So this is how you manually management of many YAML files under the Helm deployment. By using Helm, your team can use the Helm to standardize, simplify, and implement reusable deployment packages. All right, do not forget to clean up the resources. I was using the sandbox environment from Microsoft. So if I minimize it, I go to the resource group. This is my resource group. I would click on delete resource group, copy the name, paste it. Okay, if you want to see the resources from the portal, I guess. Right, so you have node pools, your private port CIDR, service CIDR, DNS service IP, Docker bit CIDR. So we'll discuss all these things in the. I will try to share the significance of these things as well. Right, but for now, go ahead and delete these. Delete, copy, paste, delete. And you can also wait till the deletion is done, or you can exit out of the portal. It will be deleted, right? So I hope this was informative to you. Please mention your queries in the comment section, and I'll see you guys in the next video. Thank you. Have a good day.